Hello viewers, today in this program we will discuss annuity and fund value. This is very important part of business mathematics. Annuity is the value at every installment of recurring amount payable in bank or gaining from bank. One who is depositing some money every month in bank, then its calculation is given by annuity fund value. Similarly, if a man borrow the loan, he has to pay the amount in installment, then its total amount is calculated by the study of annuity. Now, I am going to explain you some terms used in the study of annuity and fund values. Some basic definitions here are: annuity, a sequence of payment of equal amount made at equal interval of time is called annuity. The installment, the size of equal payment of an annuity is called installment. Payment period, the period of time between successive installments of an annuity is payment period. Term, the time period between the first and last installment of an annuity is called term. Then annuitant, the person who receive the payments of an annuity is called annuitant. Here we have discussed the basic definitions used in the chapter of annuity. Kinds of annuities. Annuity certain. An annuity is called annuity certain if the number of installment in the annuity is fixed. Bank recurring deposit is an annuity certain. Annuity contingent. And annuity is called annuity contingent if the installment are paid till the happening of some specified event. Perpetual annuity. An annuity is called perpetual annuity if the installment are paid forever. Here we have discussed the three type of annuity: annuity certain, that is having fixed number of installment; annuity contingent, that is having the number of installment till a specific event; and perpetual annuity is the annuity forever. Kinds of annuity based on the time of payment in the payment period. There are two types of annuity: annuity immediate and annuity due. An annuity is called an annuity immediate if the payment of installment are made at the end of the corresponding payment periods. An annuity is called an annuity due if the payment of installment are made at the beginning of the corresponding payment periods. Here we have discussed the two type of annuity. The first, annuity immediate, in which the installment is calculated at the end of the time period, may be monthly, may be yearly, and in the annuity due, it is calculated in the beginning of the month or beginning of the year. Now let us discuss deferred annuity. An annuity is called deferred annuity if the first installment is payable after the lapse of some specified number of payment periods. The time that lapse before the payment of first installment is called deferment period. Payment of house building loan is an example. Here when we borrow the house loan, we pay some installment and then we stop the payment, then again we start the payment of installment, that is called deferred annuity. A fund is called sinking fund if it is accumulated through installment of equal amount and the accumulated amount is meant for the discharge of some specified financial liability after the term of the fund. In business, sinking funds are used for replacement of wasting assets such as plants, machinery, or for the liquidation of loan, etc. The sinking fund is generated by depositing some amount for a particular purpose. Now, I am going to explain you the present value of annuity. Amount of an annuity. It is defined as the total worth of all the payments of the annuity under consideration at the conclusion of the annuity. It is equal to the sum of accumulated values, principal plus interest of all installment at the end of the term. Let each installment of n periods amount rupees A and rate of interest is r% per period. Then we can calculate the amount of annuity in two different cases. Case 1, annuity is immediate annuity. In this case, the first installment will earn interest for n-1 periods, second installment for n-2 periods, and so on. The last installment will earn no interest. Here the annuity immediate, in which the interest is calculated at the end of the year. Therefore, in the first installment it is for n-1 periods, in the second installment it is for n-2 periods, and the last installment is for 0 period. We will calculate the interest on these periods and find the value of annuity. Amount of annuity A multiplied by 1 plus r upon 100 to the power n-1 plus A 1 plus r upon 100 to the power n-2 plus and so on A 1 plus r upon 100 to the power 1 plus A 1 plus r upon 100 to the power 0, that is equal to A multiplied by 1 plus I to the power n-1 plus 1 plus I to the power n-2 plus and so on 1 plus I plus 1, that is equal to A 1 multiplied by 1 plus I to the power n minus 1 divided by 1 plus I minus 1, that is equal to A 1 plus I to the power n minus 1 upon I. Using the formula Sn is equal to A Rn minus 1 upon R minus 1, that amount is equal to A multiplied by 1 plus I to the power n minus 1 upon I. Here we have calculated the amount of annuity by adding the all amount after every time of period. Here the summation is formed by using the formula Sn is equal to A Rn minus 1 upon R minus 1, that is the sum of geometric progression of n terms. Now I will explain you the second case. Case 2 is annuity is due. In this case, the first installment will earn interest for n periods, second installment will earn interest for n-1 period, and so on. The last installment will earn interest for 1 period. Here in this type of annuity due, the interest is calculated at the starting of the year. Therefore, the first installment remain for n number of period, second installment remain for n-2 period, and the last remain for 1 period. So, we calculate the interest on these periods as follows. Amount of annuity becomes A 1 plus r upon 100 to the power n plus A 1 plus r upon 100 to the power n minus 1 plus and so on A 1 plus r upon 100 to the power 1, that is equal to A multiplied by 1 plus I to the power n plus 1 plus I to the power n minus 1 plus and so on 1 plus I. that is equal to a 1 plus I multiplied by 1 plus I to the power n minus 1 divided by 1 plus I minus 1, that is equal to a 1 plus I multiplied by 1 plus I to the power n minus 1 divided by I. Using the formula Sn is equal to a r to the power n minus 1 upon r minus 1. Amount becomes a is equal to 1 plus I multiplied by 1 plus I to the power n minus 1 divided by I. Here also we have calculated the total amount by adding the amount after every installment, and the summation is performed by using the formula Sn is equal to a r n minus 1 upon r minus 1, that is the summation of geometric progression in n terms. Now, I will explain you the present value of annuity. The present value of an annuity is defined as the total worth of all the payments of annuity under consideration at the beginning of the term. If we calculate the total amount of the annuity in the beginning of the start of annuity, it is called present value of annuity. I will explain you the present value calculation of annuity in different cases. Case 1, annuity is annuity immediate. In this case, first installment is amount of V1 after one period, second installment is the amount of V2 after second period, and so on. Last installment is the amount Vn after n periods. Therefore, A1 is equal to V1 1 plus r upon 100 to the power 1, A2 is equal to V2 1 plus r upon 100 to the power 2, An is equal to Vn 1 plus r upon 100 to the power n. Therefore, V1 is equal to A upon 1 plus r upon 100 to the power 1, V2 is equal to A upon 1 plus r upon 100 to the power 2, and so on. Vn is equal to A upon 1 plus r upon 100 to the power n. Therefore, present value of annuity is equal to V1 plus V2 plus and so on. Vn is equal to A upon 1 plus r upon 100 to the power 1 plus A upon 1 plus r upon 100 to the power 2, and so on. A upon 1 plus r upon 100 to the power n, that is equal to A multiplied by 1 upon 1 plus I plus 1 upon 1 plus I square plus and so on 1 upon 1 plus I to the power n, that is A multiplied by 1 upon 1 plus I multiplied by 1 minus 1 upon 1 plus I to the power n divided by 1 minus 1 upon 1 plus I, that is equal to A 1 minus 1 plus I to the power minus n whole divided by I. Using the formula Sn is equal to A 1 minus Rn upon 1 minus R. The present value is equal to A multiplied by 1 minus 1 plus I to the power minus n whole divided by I. Here we have calculated the amount of total annuity by calculating amount per annuity V1, V2, V3, Vn. The amounts here A1, A2, An are calculated as equal amount A. So, I replace A1, A2, An by A in this calculation, and we have used the formula Sn is equal to A 1 minus Rn upon 1 minus R, that is the sum of geometric progression of n terms when the common ratio is less than 1. Case 2, annuity is due. In this case, first installment is equal V1 itself, second installment is amount of V2 after one period, last installment is the amount Vn after n minus 1 periods. Therefore, A is equal to V1, A is equal to V2 multiplied by 1 plus R upon 100 to the power 1 and so on. Last A is equal to Vn 1 plus R upon 100 to the power n minus 1. Therefore, V1 is equal to A, V2 is equal to A upon 1 plus R upon 100 to the power 1 and so on. Vn is equal to A upon 1 plus R upon 100 to the power n minus 1. Therefore, present value of annuity is equal to V1 plus V2 plus and so on. Vn is equal to A plus A upon 1 plus R upon 100 to the power 1 plus and so on A upon 1 plus R upon 100 to the power n minus 1, that is equal to A multiplied by 1 plus 1 upon 1 plus I plus and so on 1 upon 1 plus I to the power n minus 1 is equal to A multiplied by 1 multiplied by 1 minus 1 upon 1 plus I to the power n whole divided by 1 minus 1 upon 1 plus I, that is equal to A multiplied by 1 minus 1 plus I to the power minus n whole divided by I upon 1 plus I, that is equal to A multiplied by 1 minus 1 plus I to the power minus n whole divided by I upon 1 plus I. Using the formula Sn is equal to A 1 minus Rn upon 1 minus R. Therefore, present value is equal to A multiplied by 1 minus 1 plus I to the power minus n whole divided by I upon 1 plus I. Here we have calculated the present value of annuity by summing the all values of V1, V2, Vn, that is the amount made at every installment, and the interest is calculated on every installment. The summation is performed by the formula Sn is equal to A 1 minus Rn upon 1 minus R, that is the summation of geometric progression when the common ratio is less than 1. Now, I will explain you the calculation of present value by taking some examples. Example 1. Mr. X decided to deposit rupees 5,000 at the end of each year in a bank which pays compound interest at the rate of 5% per annum. What will be his total accumulation at the end of 15 years? Solution of this problem: A is equal to 5,000, N is equal to 15, I is equal to 5 upon 100. The annuity is immediate, therefore, using the future amount S is equal to A 1 plus I to the power n minus 1 whole divided by I. We have S is equal to 5,000 multiplied by 1 plus 5 upon 100 to the power 15 minus 1 whole divided by 5 upon 100, that is equal to rupees 108,000. This calculation is performed by using logarithmic calculation or scientific calculator. Example 2. Find the future value of ordinary annuity of rupees 1000 per annum for 3 years at 10% per year compounded annually. Here A is equal to 1000, n is equal to 3, I is equal to 10 upon 100. The annuity is ordinary. Therefore, using S is equal to A 1 plus I to the power n minus 1 whole divided by I, we find 1000 multiplied by 1 plus 1 upon 10 to the power 3 minus 1 whole divided by 1 upon 10, that is equal to 3310. Here we have calculated the value of the annuity in 3 years. So, 1000 rupees per year amount to rupees 3310. Here one gain the 310 rupees. Example 3. Find the present value of annuity of rupees 2000 payable at the end of each year for 10 years if the money is worth 4% rate of interest per year. Solution: A is equal to 2000, n is equal to 10 years, I is equal to 4 upon 100. Therefore, V is equal to A 1 minus 1 plus I to the power minus n whole divided by I equal to 2000 multiplied by 1 minus 1 plus 4 upon 100 whole power minus 10 whole divided by 4 upon 100. Therefore, its calculated value is 16195. Here we have calculated the present value of annuity of rupees 2000 for 10 years at the 4% rate of interest, and its amounts to rupees 16,195 rupees. Example 4. Find the present value of an annuity of rupees 1200 payable at the end of each 6 months for 3 years when the interest is earned at 8% per year compounded semi-annually. Its solution is A is equal to 1200, n is equal to 3 into 2, that is 6, I is equal to 8 upon 2 divided by 100, that is 4 upon 100. V is equal to A 1 minus 1 plus I to the power minus n whole divided by I, that is equal to 1200 1 minus 1 plus 4 upon 100 to the power minus 6 whole divided by 4 upon 100. Therefore, the present value is rupees 6290.21. Here in this problem, we have calculated the present value by double the time period, because the rate of interest compounded semi-yearly and we have half the rate of interest, 8% is given, we have taken 4 upon 100 as I. From this example, I tried to explain you the calculation of present value of annuity using compound interest annually and half yearly. In this part of program, I have explained you the annuity and fund value. I have explained you the calculation of annuity in every installment, the fund value after an installment in different cases, annuity due and annuity immediate. In the annuity immediate, we have calculation after the whole period, and in the annuity due we have calculated the interest in beginning of the time period. Here in this program, I have also explained you about different type of annuity and sinking fund of the annuity. I hope you have enjoyed the program. Thank you.